Okay, I have a population of adult heights that are normally distributed. And so here is my distribution. I don't know the mean, I don't know the population variance, so I want to estimate them. So I take a sample, it's not a very big sample. I take 5 people out of this population and I measure their height and I average that number. And that's a pretty sensible way of estimating what the mean is. Let's not worry about estimating sigma squared. I'm only going to talk about the mean in this video. So the trouble with this is every time I take 5 people out of the population, it's going to be a different 5 people. I'm going to get a different mean, and so my estimate for mu will be different. So I need to understand what is the distribution of the mean of these numbers. And you should always do this. If you're combining variables, you need to know what the distribution is before you answer questions about it. So here is the variable that I want to know what the distribution is. And you should be thinking, right, this is expectation algebra. Now, when you see expectation algebra, you should be thinking, I'm going to use the formula book, because this tells us how to combine variables. This bit here is if you have one variable and then you adjust it. Let's say x is the IQ, and you say I want to double everybody's IQ and add 50 to it. What would happen? Well, I would expect the average to be doubled and I would expect 50 to be added to the average. However, adding 50 to everyone's IQ doesn't change how spread out they are. That's why this b disappears. And doubling everybody's IQ is going to quadruple the variance because it's doubling the standard deviation. So that's what that's talking about. But I'm looking at this. I want to combine many variables, so I'm using this one. Now it must look like this, so I need to slightly adjust that one. So I'm going to rewrite this like that. And now I can see I've got exactly what I want. What is the expected value of this? What is the variance of it? Now expected value is very easy. You just basically multiply everything out. Now what does this mean? This means what would you expect some random bloke picked from the population? How tall would you expect them to be? This is a mathematical word, expect, which is saying what's the average bloke? So I would expect the average bloke to be the average height. And so I have 5 of these, each of them at 1/5, and so that adds up to the average. Now if you think about that, that's completely obvious. If I take 5 people from the population and average their height, I would expect that number to be the average height. So that makes sense. How varied is this this mean number here? This is the mean. Remember, it came from here. This is the mean of the 5 people. How varied is that? Well, now I'm going to obey the formula book, this one here. And so I'm going to get 5 of these. 1/5 squared, that's there, times the variance of h1, plus 1/5 squared times the variance of h2. What is the variance of this random person, this first person we picked out? How varied is that? We could get a really tall person, could be a really small person. Well, that is the variance of the population. So that's what variance means. You pick somebody out, it's a pretty varied number. And I've got 5 of these, which I do for each one of those. And so I get 5 times this number. So here is my expected value of the mean and my variance of the mean. So I can now put it together. I'm going to summarize now. The trouble is, this is so super cumbersome. Let's think of a better letter for it. What letter, what notation is the mean of these 5 things? And it is this crucially important bar notation. H bar means the sample mean. And I now know how it's distributed. Here's the working I did earlier, written out a little bit more clearly. And so if we have a population and we take a sample of size 5 and we average it, then we now know that this is how the sample mean is distributed. And this is the central limit theorem. Obviously it doesn't have to be a 5. I could put an n in there. It would have been all the same work. So this is, for a sample of size n, how the sample mean is distributed. Okay, that's the end of video 2. Prepare yourself for video 3.